Okay, what I was or am trying to do with this video is I've looked on YouTube and I haven't found anybody who shows a better way than what I've done for taking the dirty sine wave off of a generator and stepping it down to 12 volts, cleaning it up through a battery, then stepping it back up to the 110, 120 volts and getting a clean sine wave. So that's why I did this video. Rehash real quick. Predator generator model 6500. Inexpensive, thing works very well, but like all non-inverter generators, it is a dirty sine wave coming off that thing. So what I did is first I'm running what they call a line conditioner, and the main thing for that is to prevent any possible voltage surges that come off that generator. I wasn't really expecting it to clean up the sine wave. If you watch, as you watch the video, you'll see that the sine wave coming off of the line conditioner is still a pretty messy sine wave. Run it into my 12 volt battery charger. I'm going to figure out and buy a regular power supply, 12 volt power supply, rather than that, and something that will keep me from overcharging my batteries. Ran the batteries in parallel, and the reason for that is I bring the power off the battery charger, positive side onto the terminal, positive terminal on one battery, negative onto the negative of the other battery. I'm running the batteries in parallel, and then I take my power off of the opposite ones. And what that does is it forces the juice through the batteries first, which helps clean it up, and then I put it into my pure sine wave inverter. When I've got some little 300 watt unit, I'm going to have to buy a couple bigger ones for what I want to use it for. But that's how I did it, and as you saw in the video, I cleaned that sine wave up pretty good. This is the unit, the multimeter. I got this from Amazon. Got to hold it up here. It's a professional waveform multimeter, LM2001. I'm not sure who the heck it is, but it works pretty good. The only thing, as you saw or will see or saw in the video, the buttons tend to stick on this thing. So when I'm trying to hold one thing and trying to push the button and that kind of stuff, it was a little rough. But I finally was able to show what happened. But I like this multimeter. The Bliss X, I think that's how you pronounce it, pure sine wave inverter, 40 bucks. For 50, I don't remember. Works fine. I'm going to get the bigger ones. I'm going to get a couple of 500 watters, and that way, when I'm planning on driving, is my wife's computer in the front room, and then our cable box and our TV set, and the internet connections. That's it. So I'm guessing I'm going to be probably maximum 600-700 watts draw on that side. I'm also going to run uncleaned energy into my refrigerator so I don't lose that. And as I said in the video, the reason I'm doing all of this is PG&E is saying we're looking at 10 years of summertime power outages when winds kick up and that kind of stuff. And last year I tried dry ice. Cost me a freaking fortune, and I barely saved any of my frozen goods. So that's the reason for this generator more than anything else, and I chose the 6500 watt generator, max 5500 watt running, and that was so I can just dry this stuff in my kitchen. My refrigerator was about a 2500 watt startup draw and 700 watts running draw, and then a few lights, and then the TV set, the one computer, and the internet. So again, thank you for your time. And I hope you enjoyed or will enjoy the video, depending on whether I put this part in front or in back. Thank you for your time. Okay, here's my setup. I've got the Predator generator. This is the 6500, 5500 working watts. Bought it from Harbor Freight. And if you look close here, I've got the ground hooked up, running through this black wire. And what I've done right down here is I got a split here. I can run it into a grounding rod, but I also ran it straight into the ground of the household thing. There's only one wire basically hooked up, so I've got nothing but ground. My project here is I'm going to try and clean up the AC current coming off of that Predator, which is very dirty. I'm going to come through the power line. I'm going to come into this line. What do they use? The term they use? Basically helps clean up the current a little bit. Then I'm going to run this battery charger into that. Battery charger is already hooked up to these twin batteries, and if you take note, they're hooked up in parallel, bringing the power in, negative side here, positive side here, and then my pure sine wave inverter will come from positive here, negative here into the converter. That way it forces the juice through the batteries first. And then on this little 300 watt inverter. I've got a multimeter here, which also shows a pretty good representation of sine wave. And I'm going to test the system from the Predator generator all the way through everything I've got here and see the difference in the sine wave plus the voltage. I'm going to sign off for a second here until I get everything set up. Okay, I'm going to try and make it so you can hear me. We've got a 1500 watt load going on it. And then I've also run my lines to this plug, dirty AC off of that, little cleaner on here on the line conditioner, then into a 12 volt battery charger, charging the batteries, coming out of the batteries into a pure sine wave inverter. I'm going to test things at each juncture to see just how good we're doing. One thing I'm going to show you right here is I've got a good ground. The light is green. That, again, everything's grounded in here. I've even got a line running from this unit here into the wall outlet. If you can see that orange one that's plugged in, that is all grounded. Everything's grounded on this thing. So now I'm going to sit and start testing. First thing I'm going to test, bend this down. I'm going to test first the AC voltage coming off of this. Okay. Bigger ones are always your common or your, okay? Got to get it to touch. Let's try one of the other ones. Okay, 119.9, 119.8 volts AC. I don't know if you can see it or not. Okay, that's what's coming in, just raw off the current. I am going to try and get a decent okay, 120. Okay, I'm going to show this to you. You can see just how rough that sine wave is coming off the generator. It's not as bad as I was expecting, but it's there. Okay, next position. This is on. I'm going to check first. I'm going to check first what the... Now, I'm already hooked up, so I'm going to check and see what the... Okay, you can see again, it's not the cleanest sine wave. It's there, it's not the cleanest. And we're looking at 100, 221 volts. Okay, next step. I don't know if you can see it, but we're pulling 6 amps through the battery charger. Okay. Switching to DC volts. Again, I don't know if you can see it. Yeah, barely. Okay, input voltage. .1 volts input. Same thing. Coming across, get a little bit of voltage drop across the batteries. 13.12, 13.24. Let's call it just shy of 13.5 volts out. Okay. That's DC, I'm not worried about the sine wave. Okay. Again. And this is the biggie. Okay. AC volts off the pure sine wave generator. $117.6. We're going to go to sine wave. No wonder dang things are sticking. Come on. Do something here. Turn it off and redo it. Yeah, I think you can see it, how much cleaner that alternating is. It's right at 59 hertz right now. And I'm going to flip over here. $59.9 hertz. Clean sine wave. So if you're interested in cleaning up your sine wave off of your non-inverter generator and getting a clean sine wave, this is one way to do it. Nice clean sine wave coming off of there. Also, if you need, if the batteries are fully charged, you can run the inverter without the compressor going. In my, or the, not the compressor, but the generator. In my case, I'm also going to be driving my refrigerators and stuff because of dear old PG&E and their power cutoffs during the summer. That's the reason I'm putting this system together. Again, thank you for your time. I appreciate it if you're watching.